So, hi folks. My name is Omkar, and as Lakshay mentioned, I am a AI, ML, and Gen AI lead at Venture Technologies. We are a service-based company, so which means I work with a lot of companies in BFSI, retail, QS, and other markets, uh, specifically to build products, platforms, or solutions. Right. Uh, Today we'll be looking more on how the Zyte API can be leveraged to unlock certain new use cases which were previously much deeper uh, regarding scraping. Right. So there are five, six things which I would be covering in today's presentation. One is the traditional web scraping limitations. How Zyte API and LLM can work together to overcome those real world applications, few case studies which we have done and are possible. Uh, in that, how do we, apply that? How do we build a scalable architecture, which in a cost effective manner we can build to solve some of these problems at a very large level. And then there are some of those challenges and best practices around it. And then we'll have a few minutes to do the QA. Right. So that's how I'll be structuring this particular presentation. I think this is something all web scraping enthusiasts already know, right? So these are the four main issues of your traditional scraping pipelines. There are a lot of bot protections, which all these, especially these e-commerce websites, are really stringent about, right? The captchas, they're continuously updating these things, right? You try to have proxy management, like somewhere try to go from US, Europe, or there are so many ways that people try, but with people trying, these companies are all do catch up and they also accordingly modify it. Similarly, the websites do a lot of HTML changes, so your script has to actually take care of that, as well as it's a huge unstructured content, cluttered content. So you need to, add that to the mix. So these are your traditional scraping problems. I think everybody here would be aware of that. So Zyte API, I think people in this particular group, I think they would be knowing what a Zyte API is. So one good thing about this Zyte API is it can take care of your captcha. It can take care of your JS rendering part, your geotagging part. So let's say one particular website, let's say something like let's go for an e-commerce site, right? Like Macy's or Kohl's or something, right? If you are not able to extract the data that you want from that a particular website, you can you know add GS rendering and it can give you that data, or you can geo target it from a different country or continent, right? So that can help you do uh, that can help you extract a lot of data on which you can put LLMs to get specific insights, right? So let's say, if it's for research teams, you can go to RWix and get a lot of data. And once you have collated that, you can actually put that into an LLM to get specific insights about it. If it's an e-commerce platform for a certain product, if you're doing this, based on the product, the page content, you can extract, what this whole product, this apparel or whatever you want to, look for is all about, right? You can get those specific things. And of course, there's a tech stack which will allow us to actually do it at scale. Like for example, the Site API, there's then of course an LLM, there's a vector DB to store all these vector embeddings, and of course there's a language to run this thing, which is Python. So these are the four things. So what are the real world use cases, right? These are some of the use cases which uh, I have seen, some of which we have done with customers. Since we are a services organization, we work a lot with enterprise as well as startups, right? We work with startups pre-funding, post-funding as well. So if you look at pre-funding startups, they do not have kind of money, right, which they can put if they want to really build a product which has scraped data from a lot of places, right? So how do you ensure that your product that you're building has data across millions of web pages across the web, right? So that is where you need to look for a cost effective way to scale this part. Of course, for enterprises it's more simpler. The third one, which we look at, the competitive pricing part, is something which classical enterprises do. This is a typical retail use case, right? So any retail aggregator uh, would love to have this. See, I know I'm putting a product for this much dollars. What are my competitors putting it from, right? So that is something which is really powerful there. I think empowering research team is something which is a very straightforward and a very, you know, which is their kind of use case today. Intelligent product discovery, product copies, all those things are also now, once if you're able to scrape that e-commerce websites using these kind of engines, you can make these kind of use cases happen, right? So these are some of the use cases. uh, what are the main features which these LLMs can now give you, right? Summarize highlights, right, across all these pages, whether that might be a research use case, whether that might be a product based use case from an e-commerce website, or you want to get some pricing, right? You're saving a lot of time. You don't have to look at it manually, neither have you need to go and to look into a specific Python code for each website to do that, right? So that saves a lot of time. Basis your architecture, if you have a good scalable architecture, it can actually help you to put a lot of time, and the maintenance is quite low. This is usually achieved by using a cloud today, either an AWS or as Azure or a GCP. If you are into any of these three clouds, I think this is something which come with them if you're using the right services. Like for example, for storage we have S3 and AWS, right? So it is kind of a very cost effective. I think S3 is the most cost effective out there, as well as it has a very high durability rate. So these clouds kind of take care of that particular part, as well as how to use a Zyte API to really scrape a lot of web pages, right? For example, what I'm claiming today here is I scraped 10,000 web pages in a day. Right? That's what I'm claiming here. So what I would do is, in the next few slides, I will take you through. One is, how do I use my Zyte API? I'll take you to the Zyte API and what I'm putting there and what I'm getting the output. And second, I will show you a sample architecture which I've built for you. And what are the various components which I've built to ensure that I can actually scrape these 10,000 web pages a day, as well as get meaningful insights from it without actually putting a lot of money in this, right? Because if you're a startup or something, uh, you can't burn a lot of cash, right? That's the primary thing, right? So we'll go into these three things. So I'll just quickly change my screen. Let's go to the first part. So let's say, let's go to one of the e-commerce websites. I just had this open for this particular demo. I'm looking at Macy's website, right? So this is one product, some Adidas men's Tiro 24 league, and I want to scrape data from this, right? So what I do is I click on this and I put it here, right? I've just had it ready for you. Uh, I'm just getting the HTML content out of it as well as the structured data out of it. What it does is it took 200 seconds, sorry, 3.588 seconds to get you the data. This is the cost that it gave you. This is typically the HTML content that it will give you. It's like to just get all the data right from that particular page. If you want to kind of, if you are into scraping and you know where to look for, you will go in the LD plus JSON section in this particular case, and kind of get that particular data, right? So if you have brand here, your name here, and so on, right? So this is what you'll do. One more thing that Zyte API helps you is they have something called a structured data. Right now we are a selected product. These are some typical, parameters that you want when you're looking for product information, right? So that is something that it gives you. You would want the name of the product, the price of the product, the URLs, the breadcrumbs, so that you can track that product, the SKU, uh, since it's a unique SKU for the website, the pricing, if it's in stock, its rating, best ratings, and so on, color, polyester, fibers, etc. Right. Once you have that, I think the next steps are pretty clear. You can just use that particular API key, put that into your code. You can track your pricing here, and you are good to go ahead, right? So That's how you can use that API. Just wanted to give a high level understanding for those who have not used an API and how it is used. This can help you circumvent most of the issues that comes while you want to scrape manually without using a Zyte API, like your proxies, your captchas, your bots, figuring out all the cluttered content, and so on. So this is something which can help you there. The part one, right? Once I have this in place, right? I have this in place now. I know a way in which now I can get data from a certain product page, from a certain, maybe that's a research website like an Arvix or some other website, right? Once I have that, I need to create a mainframe which, in a scalable way, can actually derive insights from that very cluttered HTML content that I got, right? Because for me, right now, the Zyte API is able to give me certain product details. I might want certain more things. The things I want might not be there, and something that the Zyte AI engine is providing to you, right? So how do you build that? Yeah. So this is a very sample mainframe which I've created. This is built on AWS. Similar can be built on Azure or a GCP, or even on your local system for that matter. Right? I think this is a very small in size to look at it, but let me explain to you. For people who know the AWS system, of if you want to really make it cost effective, there is something called as Lambda, AWS Lambda functions, right? What these Lambda functions do is uh, they kind of give you compute for 15 minutes. They have a limit of 15 minutes and they have like 10 GB RAM and so on. There's certain limitations, right? And the good part is uh, somewhere close to 1 million requests per month are free. So there are certain limitations, that is the kind of storage, the RAM, and all that you can use. But this engine, this Lambda function engine, can actually help you to lower your cost, because in this whole scenario, the first part where you actually want to scrape your data, eh, it's essentially a API call that you're going to do for a site website, right? So you actually don't need a very big compute to do that. You can essentially do that in your local system. So the Lambda here is just trying to mimic your local system. So let's say I want to run a scraping logic for 10,000 web pages, right, in a day. What I would do is Lambda functions come with something called as batching and concurrencies, right? So essentially, I give I write a simple Python code where I give a CSV and say, hey, look, man, here are the 100 web pages or 10,000 odd web pages that I'm giving you, and you kind of run through this and scrape this data basis the data that you get from the site API, right? And you put some batches to it, like we can put 100 batches so that one after the other it will go through all the codes, and you can put across concurrency, so 10 concurrency and 100 batches or something like that you can do, so that continuously till what it does is essentially it will concurrently run 10 web pages as well as one after the other it will batch for 100 for all these 10 concurrencies, right? So this can quickly in few hours give you all that 10,000 web pages, right? I think when I did that it took me somewhere around 4 odd hours to get this particular data for 10,000 odd web pages. Now this is something which will give you that HTML part that we saw as the Zyte API's output, right? The second part is if you actually look at the output, the HTML output, it will have like somewhere around 20,000 tokens, 30,000 tokens, right? If you are trying to give that to an LLM, you are going to have huge cost coming up to you, right? Because 20,000, 30,000 tokens, and you want to do this for 10,000 of web pages, that's a lot of cost to manage, right? So you can't do that. Plus, at the other hand, the data you are getting, not the whole data is relevant for your use case, right? You want to extract certain use cases, certain data only basis your use case, right? Hence, I have put here a cleaner logic. This is again a Lambda function so that it's practically becomes free for me to run this. It's again a simple Python code what I've done in this case is uh, just written a logic to look at certain places in my the HTML function, the HTML code that I get, right? If, for example, my name, brand, product, URL, and so on, use and so on are placed in LD plus JSON, right? In most of the cases, I'll pick that up, and all the other parts, relevant parts I need like scripts, meta tags, and so on, and I'll remove the rest, right? So that what happens is at the end of this exercise, what we were able to do was get from a 20,000 odd token web page data to a 3 to 4,000 web page data, right? So once you have around 3,000 odd tokens for these 10,000 web pages, that is where you can actually run and extract logic. When I mean extract, this is where your LLM actually comes in. So what LLM has to do is now simply go into the actual relevant data that it has. And the next part is more about your prompt tuning, right? You need to tell it, okay, this is the kind of data I'm giving you, and I need this. I need, let's say if it's a product of Macy's, as we just saw, I need the product ID, I need the SKU code, I need the EIN, and so on. Last part is more about a retry logic. It it does happen a very lot of time. That will happen that a particular logic did not run for a certain websites. Out of 10,000, it is very common to see that 50 or 100 web pages didn't work. Right, that's very common. So we just retry this whole again, and this is completely orchestrated using the AWS step functions. So what step function essentially does is it's like an orchestrator, right? One after the other, like after step one, step two, step three, and step four. So that it's like an actual button click. As you click a particular button, everything runs by itself, right? So that's a kind of a scalable and cost-effective workframe uh, that we have created. Here, there are only two major costs that you will get. Number one is for the Zyte API. You need to see where do you actually want to run that structured data wala AI engine. You need, or where do you want to put GS renderings, right? So there are certain websites where GS rendering might be required to get certain data, and there are certain websites where it might not be needed, right? So it is up to you to understand which for which websites I need to put that, so that you can accordingly take care of the cost, and you can arrive at a decent number, right? For me, I had a certain restriction. Okay, I had this particular 3,000 odd dollars in which I needed to scrape so many thousands of web pages. Right? That's one uh, this thing, and in the same amount of dollars, I like together like scraping plus the extract logic. I also had to extract the relevant, insightful data from my LLM. Right, so all those 10,000 pages, once I get it from the cleaner logic, I need to give it to that particular extract logic. So once you get that, the LLM, there is certain input token cost, there is certain output token cost, right? So basis that you need to ensure that you use a right LLM. You don't go for something like GPT 4.5 or Claude Sonnet 3.7 and so on. You can, if you want, use a open source LLM, or something that let's say even Llama 3.1. There is, I think, a 1 billion or 3 billion version which comes out there, right? So even those kind of works for these kind of use cases. So basis your use case is something that you need to figure out which LLM to use. This is something which is very interesting, right? This actually tells us how outputs at each stage look like. So if you look at the first one, this is your actual script data, the doc type structure, right? This is a completely cluttered data. As soon as I give it to my cleaning script, which is a basic Python script, which is kind of made generalized for websites that you give, it will only give you those relevant data. And the third part, which you see, is extracted data using LLM. So if you look at it, you will see product ID, and there's a certain value to it. There's a name. So it's a propagation structure in which you actually get only the relevant parameters that you want, right? So this is how you can actually look at those. So now there are certain there are certain algorithms or there are certain libraries which do all these three things parallelly, right? We have even tried that. But if you want to do this consistently, uh, this is the way which you will have to do, because there are certain graph based libraries which very easily do this. There are multiple of them. But when you actually do that at a scale which I'm just trying to explain to you, like 10,000 odd web pages per day, if you try to do that, it might not always give you very consistent output which any client would look for, right? So multiple startup, if you want to try something, you will need a very consistent output. So this is an example of a pipeline that can give a very consistent output. I've seen that over many months now. So we've been working with this client for many months now. It's in production. So we know that it can give us consistent output. So that was part one. The last part which I wanted to look at is there it's and in the end it's an LLM, right? So it can hallucinate, right? Let's say you are trying to scrape from 10,000 odd web pages. The LLM might hallucinate for 500 odd pages, 1,000 odd pages, right? How do you take care of that? So there's one thing, how do you reconcile that? So what we try to do in these cases as a best practice is we try to create a reconciliation script, right? A QA script. What it does is it goes into your HTML content that you get from the scrape data. That is where you have an HTML content. We reconcile the value in the clean data, or let's say for example in the extracted data. Let's say I'm saying my product ID is so and so. I go and do a simple Python regex function and just check if that particular value is there in my scrape data or my clean data, right? So that is level one, to just check if those values are present. Now it might happen that when you're using LLMs, uh, it might sometimes summarize it. It might not give you data in the exact same wordings, right? It can change the wordings. LLMs can do that. Basis how you have put your parameter tuning, right? So what you do in this case is there is a certain libraries in Python itself which can give you approximate probabilistic scores. Like some, like for example, one which is a very common and a popular library is Fuzzy Wuzzy, right? So it can give you a probabilistic score. This particular wordings which you are, you know, which is there in this extracted data, it's 70% close to what is there in my scrape data, right? And basis that, you can have a threshold. Like if it's 70% close, 50% close, I'll proceed with that, right? So basis that you can actually check on an individual level, on an automated manner. It's not something that you need to go through every script and every output and check it. This is something which can happen in parallel in very automated fashion, right? We spoke about cost and latency. We spoke about hallucinations, and we spoke about scaling. Now, how do you use this in a downstream application, right? That's the last part which I wanted to cover as part of this presentation. Uh, let's say you get these 10,000 odd pages in a day or so. What you can do next is create a vector database. Uh, these AWS platform, like all these cloud platform, like for example, AWS has like something called as open search. If you look, there are so many today open search, open source uh, vector databases, right? Yeah, there's Fairs, there's Milvers, there are so many others, right? So you kind of vectorize all this. There are multiple ways in vectorizing that. That's a completely separate discussion. How do you want to vectorize it? At what level do you want to vectorize this? And so on. So that once you have a database in place, you can connect that to, let's say, a chatbot, which can help you with your research team, which can help you with your, product discovery, which can help you with the product pricing, and different teams, right? If you want, you can add an agent to it. If you want to combine all these things and give it to different stakeholders, there's an agent which can look at, okay, what is the kind of query, and then go in that particular database, do that particular workflow and hit it, right, and give you the answers. So that's how you can use these the scraping pipeline to actually power downstream applications which were very difficult before. So this is what I wanted to cover as part of this presentation. Any questions?